Okay, dear students, let's start with another PYQ. The maximum and minimum shear stresses in a hollow circular shaft of outer diameter 20 mm and thickness 2 mm subjected to a torque of 92.7 Newton meter will be. Okay, so here we are supposed to find out maximum and minimum shear stresses. So let's draw a hollow circular shaft. So hollow circular shaft will look like this. This is your okay, so hollow circular shaft. Now thickness is 2 mm, so this is your 2 mm, this is 2 mm, this part is 2 mm thickness, okay, on both the sides. And they have given us outer diameter, so this much portion, outer diameter capital D 20 mm. So obviously inner diameter will be capital diameter, capital D means outer diameter minus 2 times thickness, so 20 minus 2 times your thickness, so it will be 16 mm. So this is your small d. Okay, now they have given us the torque, that is 92.7 Newton meter. Here we have to be slight careful because every dimension is in mm, so let's convert it into mm. So 92.7 Newton into its meter, so we have to multiply by 1000, so this will be your Newton mm. Okay, now let's apply the formula. So the basic formula which we will be using here is your tau by r is equal to T upon IP. So tau is the shear stress, r is the radius. Okay, now here we are having two types of two radius, one is inner radius and outer radius. Okay, so we will get two values basically, tau max and tau minimum. We are supposed to find two values of shear stress. So maximum shear stress we will get by using outer radius. Minimum shear stress we will get by using the inner radius. Okay, so then capital T is your torque, which we know 92.7 into 1000 Newton mm. IP, what is IP? IP is nothing but it is polar moment of inertia, basically it is Ixx plus Iyy. So we know for circular section it is pi by 64 capital D raised to 4 minus D raised to 4 because it is hollow section. Okay, and Ixx and Iyy both are equal, so I will multiply it by 2. Okay, so it will be pi by 32 D raised to 4 minus D raised to 4. So here D raised to capital D is 20. So 20 raised to 4 minus 16 raised to 4. So let's find out how much it is. 20 raised to 4 minus 16 raised to 4 into pi by 32. So it is around 9273.98. So it is 9273.98. This is in mm raised to 4. Okay, so let's put up all this value in this formula. This is our basic formula which you are supposed to memorize. So tau by r. So let's find out tau max. For tau max we will be using outer radius. So outer radius means outer diameter. Our outer diameter is 16 mm, right? So outer radius will be our outer radius diameter is 20 mm, so it will be 10. Outer radius is 10 is equal to T, we know it is 92.7 into 1000 divided by IP value, just now we found out 9273.98. so tau max will be 92 92.7 into 1000 multiplied by 10 divided by 9273.98, it is 99.95. okay, so basically here the answer is 100. okay, so 100 MPa. no need to find out another value, but still for the sake of doing this sum, tau minimum divided by, now we will be using inner radius. so inner radius is our it will be half of 16 mm, so basically it will be 8. okay, is equal to same 92.7 into 1000 divided by 9273.98. so tau minimum will be 92.7 into 1000 into 8 divided by 9273.98 is equal to 79.96. so basically the answer is 80 MPa. okay, so 80 MPa. okay, I hope you got this. okay.